The problem that I would like to teach you how to solve in this series of videos is how to upload files. Now this seems to be a very easy operation, but we will discover it's actually not very easy. The problem is this: we have a big file or even a small file, and we have a user browser, and we would like to send this file via the browser to our server. And the real problem is, what are we going to do with the file at the server? Well, one fairly traditional idea would be to store it as a file in the file system. But this we can't really do. The problem is that once we need our application to scale, as we know, there will be several servers. There will be server 1, server 2, server 3, and so on and so forth. And each one of these will have their own file system. This is their local disk. And once a server goes offline, the file system disappears, is disallocated, is gone forever. So the file system does not actually provide us a place where we can store stuff in the cloud, okay? So we have to find some better solution. What can be this better solution? Well, you can tell me we have already solved this problem in the context of data storage normally, and we can just put it into the database. Yes, why not, okay? So this is a database. Now, the database kind of works, except that the database has a big drawback. A database is optimized to search and serve you data that is highly interconnected, the typical database tables that we have been creating for our applications. A database is not optimized and is not convenient to use to store very large amounts of data that is not organized, such as a big image, a movie, or something like that. In particular, the storage for a database is quite expensive because you are buying essentially flash memory online. You don't want your database to sit in some slow disk or some slow form of storage. So you pay a very high premium for database storage. You also replicate it in certain ways across multiple sites. So storing big files in the database is possible, but also it's quite wasteful. And so this also is not the solution we are going to use, okay? What we are going to use is a different solution. We are going to use essentially a blob store. In particular, we are going to use Google Cloud Storage, GCS. We could use also Amazon S3. Amazon S3 would also work, but we will develop our code for Google Cloud Storage. And so we will, that's where the information will go. Now you think that, okay, fine, so we upload it to the server and then the server will put it into Google Cloud Storage. Yes, pedestrian people that don't know any better do this, and sometimes it's actually necessary to do this. The drawback of this is this. Imagine that this big file is a movie, we are getting submissions to a movie contest and these people are uploading to us their multi-gigabyte movies. In this way, these huge movies would be taking all the bandwidth to our server that would use all the bandwidth to store it out in Google Cloud Storage. This is quite silly. Again, the bandwidth to our server is an expensive resource. We should not waste it to get a giant upload that we're then just gonna store somewhere else. The better way is to essentially redirect these in some way and have our browser store stuff directly into Google Cloud Storage. So our goal is the following. We want to be able to use our server to orchestrate all the data transfer, but we want the browser to upload and download files directly from Google Cloud Storage. That is sort of the holy grail, because the storage on Google Cloud Storage is actually very competitively priced. You can choose different price tiers according to how much you want it replicated or how frequently you think you are going to access the data. It's going to be distributed efficiently all around the world. And above all, Google Cloud Storage is automatically distributed. So if you have 1,000 people that are going to upload movies to your movie contest 1 minute before the deadline, those thousands of uploads from all the user browsers are all going to be going to what are in the end different machines in the Google Cloud, so you don't have the bottleneck that you would have if you directed all the uploads to a single host, okay? Google Cloud Storage is an incredibly large scale service, just like Amazon S3, And so there is no problem scaling it up. And even if your 1,000 customers are uploading 1,000 videos at the same time, well, you know, that's a small blip for the service. And it's not bandwidth that you really want on your servers. So the goal is, how do we actually get this done? In order to upload files to GCS directly, we have to orchestrate the following. So there is a browser and there is a local file, and the user at some point will express the desire to upload the file, clicking on a button on the browser. At that point, the first interaction is this. The browser will contact the server, expressing the desire to do an upload. I mark this via upload with a question mark. Okay, so this is a request to upload. And the server replies, well, this is the same, HTTP call, but let me mark it in the other direction. The server replies with an upload URL. Upload URL. This upload URL contains a file name and an authorization in order to do the upload directly to Google Cloud Storage. So in fact, the second request that happens is that the browser uses this upload URL to talk to Google Cloud Storage and store the file. So this request goes to upload URL, and the file is attached to this request. Okay, so the file will be sent directly to Google Cloud Storage. And Google Cloud Storage replies something not very interesting. It just says OK. So 200 OK, the classical success code. Once that happens, there is a third interaction. Let me mark it here. The third interaction says done. So it is the browser confirming that the upload went through. And the server will say something not very interesting, but it will reply with information about the file. So why is this third interaction necessary? The problem is that in interaction 1, you say that you want to upload and you get an upload URL. So the server is aware of your intention. What the server is not aware is whether you carry through your intention or not. The browser could die, GCS could be unavailable. There are lots of things that could go wrong at that point. And if you talk to GCS and get a confirmation for the upload, then the server does not know about it, and you need to tell the server. The server needs to keep track of which files have been successfully uploaded on GCS in order to label the uploads as successful, so that you can keep track of the files that are uploaded there and delete them in case of need. Okay, so you need to close the loop with the third request. This will be the general scheme of things we will need to do. When we need to delete a file, this will work in a similar way. There will be a first request in which we tell the server, hey, we would like to delete something. Then the server will give us a URL for GCS that will carry out the deletion. Interaction number 2 will be, we do the deletion to Google Cloud Storage. And interaction number 3 will be, we let the server know that we actually deleted the file. Okay, so things will always have these 3 steps. The 3 steps in a schematic way is ask server for a URL to do something on Google Cloud Storage. Okay, use URL to do it. And step 3, let server know it's done. Okay, so we will see these in various steps. This URL here is a special URL, and it is known as signed URL, because the URL carries with itself the permission to do the operation. Okay, so we will need to set up some authorization in Google Cloud Storage to do this. The signed URL will authorize us for one specific operation at a time. It will authorize us, for example, to upload a particular file to a particular place in Google Cloud Storage, or it will authorize us to delete a file. Every signed URL will be very specific in its purpose and also very limited in the temporal span. You can decide it, but our default will be 1,000 seconds of authorization for each operation, and you can make it shorter if you like. Okay, so this will be the principle, and this has the great advantage that all the interaction will not touch our server. I mean, all the big bandwidth will be directly directed to Google Cloud Storage for uploads, for downloads, and the deletions also are directed to it, but those don't take space. Good. So in the next video, I will talk about how to set up the Google Cloud authorization and cloud storage in order to carry this out.